Hello viewers, Wagadaruna taking you through the story of A-level pure mathematics. And this video we are going to go through the marking guide for U.A.C.E Uneb for the year 2023. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the videos we hope to upload. What is ticked means is already there on the platform. What is not yet ticked means will be uploaded with time. So today we are going to go through the marking guide for Uneb 2023 plus its report. But before I forget, these are the books in case you need to purchase some of the books in A-level. In Principal Math, there are 4 books: Math Paper 1, Math Paper 2, Termly past papers with marking guides, which contain beginning of term, end of term, midterm, mocks, and U.A.C.E, and topical question bank. Subsidiary math is only one book which contains all notes, past papers, and Uneb marking guides. Physics, there are 3 books: Physics Paper 1, Physics Paper 2, topical question bank, and its solutions. So for any of the copies, call on this number and you'll be worked upon. Okay, so a standard paper has 2 sections. Section A has 8 questions, each carrying 5 marks, and all are compulsory. Section B has 8 questions, each carrying 12 marks, and a student is meant to attempt any 5. So because this is revision, we shall attempt all the questions in the paper. So question 1 was from Algebra, and it says, prove by induction that this is equal to this. So here the first thing to do is to expand this summation. Expanding means when you put arrow equal to 1 here, what do you get? You get 1 squared. When you put 2, what do you get? 2 squared. And all through up to n. When you put n, you get n squared, equal to this expression given. Okay, then now we can start our proving. 1 is testing for n equal to 1 and n equal to 2. Is it true? So when n is equal to 1, left hand side n means the number of terms. So n equal to 1 means only 1 term, the first term. For the right hand side, okay, let's deal with left hand side. 1 squared is equal to 1. What about right hand side? Right hand side, n means substitution. I want you to remember that. Left hand side, n means number of terms. Right hand side, n means substitution. So where there is n, put there 1. Put there 1 to get this 2. Put there 1 to get this 3. So do you realize that right hand side is equal to left hand side? Then we can say that it is true for n equal to 1. That is okay, but what about n equal to 2? N equal to 2, left hand side means the first 2 terms, gives you 5. Right hand side means you substitute. So it is also still true. That's good. So before we go to the next slide, let's mark for this slide. Then now we are going to, next is an assumption. You suppose. I want you to remember this word, suppose. It is true for n equal to k. We are saying suppose because there's no way you can prove. Previously, n equal to 1 we could show, n equal to 2 we could show, but for n equal to k, where k is a positive constant, we cannot. So there we just suppose that it is true. Then we write the left hand side, n equal to k means the first k terms. Right hand side, n equal to k means you substitute where there is n, you put there k. Okay, now we can go back to our showing. For n equal to k plus 1, right hand side means you substitute. Where there was n, we put there now k plus 1 to get that, k plus 1 to get that. For the left hand side, it means the first k plus 1 terms. From here to here, it was first k terms. When you add on the next term, you get the first k plus 1 terms. So this one is the same as this, and we made an assumption that this sum is equal to this. So that's why I'm substituting for this to get this part here. My aim is to ensure that the right hand side is equal to the left hand side. So I've not yet reached it, because if you see this, it is not equal to this. So we still have some more work to do. Let me put everything under an LCM, which is 1 over 6. Now I've managed to get this 6. Do you see this? Here. That's good. What about the rest? The rest, you realize that this k plus 1 is common to this. So there's a common factor, so we factorize out k plus 1. Here, when we remove this, you remain with k and in brackets 2k plus 1, which is there. Here, when you remove 1k plus 1, you remain with 6 and k plus 1. We have also managed to get this k plus 1. But what about this? So that one, in short, it implies that when I factorize this, I must get this. Let us try to see. 1 is open brackets. So this with this is 2k squared. This with this is k. This with this is 6k. And this with this is 6. Then simplify. This and that is 7k. But I still need to factorize. So I'll need to look for factors whose sum is 7 and product is 12. So those factors are 3 and 4. So that you replace them with the middle term. Then you factorize by grouping. Group these two, factorize them to get that. Group these two, factorize them, you get that. Then from here, I realize that k plus 2 is common, so factorize it out further. You remain with here 2k and here remain with 3. So I've managed to get an expression similar to the right hand side. Then I can conclude that since it is true for n equal to 1, n equal to 2, n equal to k, and n equal to k plus 1, then it is true for all positive integers of n. And that's what they wanted. So analysis, the question, like I told you, every year after marking UNEB writes a report highlighting the weakness of what question analysis, what the question required, then 2, the weakness of candidates, what made them misfire, what made them make mistakes, not get full marks, and 3, what advice do we give to those who will sit UNEB the next year, like that. So these are the 3 parts which are found in the report. Question analysis, what the question required, weakness of candidates, what made them fail, and advice to teachers, what to work on so that we don't make the same mistakes. So these reports are available on their website. You can download them. That's why I also get them. So question analysis, the question required candidates to prove a given series involving summation by induction. And it was a popular question. Popular means it was attempted by many. But being attempted by many doesn't mean that it was well done. No. Many students can attempt a question, but they make some mistakes somewhere and they don't get the marks they are supposed to get. So what were some of the weaknesses? Many candidates were verifying instead of proving the series. So here, this word induction is very, very important. It's not similar to verifying. It's not similar to the proof which we use in trigonometry. In trigonometry, they just say, prove that this is equal to this. But in series, we say, prove by induction. So the word induction makes things different. Okay. The another weakness was failure to interpret the summation sign. Some students, when they saw the summation sign, they switched off. Then some candidates did not make a conclusion by induction. Conclusion to induction. This conclusion is very, very vital. I think you saw that it carried a mark, so 1 mark went because they didn't conclude. What are the advice to the upcoming UNEB students? Emphasize to students that proof involves both sides of the equation. That's why you saw me putting there left hand side, right hand side, left hand side, right hand side, like that. Then guide students that at the induction stage, right hand side should be completely simplified. Right hand side should be completely simplified. Some of you struggled to expand. Did you see what I did? I didn't expand the right hand side. I left it factorized. Okay. Then train students to make a conclusion that starts from the lowest value up to k plus 1. Did you see the last conclusion I made? Maybe let's first go back and you see. Here I said, since it is true for n equal to 1, n equal to 2, n equal to k, n equal to k plus 1, so all these ones are needed, lowest all through up to k plus 1. So that was question 1. Now we shall go to question 2. Question 1 was from algebra. I think you know that a standard paper contains algebra, geometry, trigonometry, calculus, and vectors. So algebra contains 2 questions in section A, 2 section B. Geometry, 1 question in section A, 1 section B. Vectors, 1 section A, 1 section B. Trigonometry, 1 section A, 1 section B. Calculus, 3 section A, 3 section B. So far we have looked at 1 question in algebra. That was question 1. Now question 2 is from geometry. It says, if a line y equal to mx is a tangent to the curve this, show that c squared is equal to 4 plus 3 m squared. Okay, so we need there some condition of a tangency. So what we do, we get this curve, then we substitute this equation of a line here to get a quadratic equation in x. So when I expand and expand this bracket, you come up with this, then put this 3 inside, you come up with that. Then rearrange in form of a quadratic equation in x. What has x squared? I put it alone. There is this x squared and this x squared. What has x? I put it alone. What has no x at all? I put it alone. So now that we have a quadratic equation in x, it means that we are can now use the condition for tangents. Condition means the roots are repeated. So b squared minus 4ac is equal to 0. So the coefficient of x squared is a, coefficient of x is b, and the one without any x is c. So come and substitute your b here, your a here, and your c here. So we have to simplify this so that it is similar to this. So let's see that in the next slide. So one, you should realize that this and this gives you 12. So I'll first pull out 12. Then I expand this times that. So let's do that. So this 12 is out. Then I expand the other 2 brackets to give you that. Why did I remove out 12? So that it can reduce with this. So here when it reduces, it remain with 3. Then I can open the entire bracket and collect like terms. Collecting like terms, do you see this and this? It cancels because of this minus. So this goes away. Here, this negative and this gives you this. Negative and this gives you positive. Negative and this gives you positive. Okay. They want C to be, C squared to be made the subject. So what I'm going to do, I'm going to take this side to come up with this. What if I divide both sides by 4? I'll come up with what they want. So that's how you could get the 5 marks in this question. Question analysis. The question required candidates to derive a given expression from the condition for tangency of a line to a curve. It was a popular question, meaning attempted by many candidates. But that doesn't mean that they've passed it all. There were some weaknesses, and one of them was failure to arrange a usable quadratic equation. Did you see what I did? Paired x squared alone, x alone, and constants alone. That was a challenge to some students. Then 2, misinterpretation of the question as an application of analysis. Most students, when they hear the word tangent, they think about differentiating to get gradient of a tangent. That is not okay. It is not okay. So this was not under calculus. It was under geometry. Advise that teachers should expose students to more examples of tangency of a line to a curve. Then teach students all the topics of conics symmetrically and early enough. Okay. Then question 3. Question 3 is, now this is under calculus. It says, given that y is equal to this, show that this is equal to 0. So there are 2 options of doing such a question, and whatever you choose is okay. So one of them is, I'll come and say, when I get this is a product, then differentiate it. Differentiating a product means keep one constant, differentiate the other, plus keep one constant, differentiate the other. Then simplify this, you come up with this. But we know that y is equal to this. So what I'm going to do, I'm going to replace this with y to get that. Then I can differentiate the second time. Differentiating the second time means keep y, differentiate y, you get dy dx. Then this is the product also. Keep this constant, differentiate the other. Then keep this constant, differentiate the other. Then simplify. Okay. Then now I'll still remember that y is this, so it can come here. So remember that y is that, and this is equal to that. So come and substitute, you come up with that. Rearrange, and that is what they wanted. So like I told you, there are 2 alternatives. That is the first one, which is a little brief. But the other one, it is also okay. You differentiate first time, second time, and then you substitute. So let's also see that if I'm given y, I'll differentiate it the first time to get that. Then also differentiate the second time. Differentiate the second time, this is the product. So second time, I'll come up with that. Second derivative, using product rule, simplify. Collect like terms. Then I'm now going to substitute. I know that left hand side is equal to that. So substitute this here, substitute first derivative here, and substitute y here. Then you simplify until you get the right hand side. So I'm going to simplify until I get 0. So do you see that ex is common in all? That is why I pulled it outside. So here I remain with this, here that. Okay, then you realize that this -6 plus 6 is 0. Then -8 minus 2 gives -10. With this to give you a 0. So that is the alternative. So there are two ways of attempting such a question. Question analysis required the formulation of a second order differential equation by eliminating the exponential and trigonometric forms that were given. Popular question, but still there were some weaknesses. One was failure to obtain the second order differential equation. Differentiating the second time was a challenge. Then majority of candidates were verifying instead of showing. So verifying is different from showing. Verifying was about trying to differentiate from first principles, which is not okay. That is not okay. Then advice to teachers should guide students to eliminate the unwanted functions to form a differential equation. Then also differentiate between verifying and showing. I think I've told you that. So some questions I will tell you differentiate from first principles, okay? Others will just tell you differentiate, so don't confuse the two. Then question 4 now is from vectors. It says find the angle between the line this and the plane this. Okay, so angle between the line and the plane, we use direction vector and normal vector. So for a line, this is the direction vector. For the normal, the coefficient of x, y, and z make the normal vector for the plane. Then we shall quote the dot product. So here we are using, now here in this case, theta is the angle between the plane and the line. But this angle we are getting here is the angle between the line and the normal. I think you know that this is the normal vector and this is the direction vector. So the 90 minus theta is the angle between the line and the normal. But the question wants angle between the line and the plane. That's why we say 90 minus theta, where theta is the angle between the line and the plane. So simplifying that from trigonometry, this can become sine. Then you can substitute for n, for d, magnitude of n, magnitude of d. Then simplify. Dotting this gives this times this is -3, this times this is 24, this times this is 8. Then square root of this is 13, square root of this is 3. Then simplify, this gives 29, this gives 39. Therefore sine theta is that and theta is that. And that's what they wanted. So that's how we could get the 5 marks in that question. Question analysis. The question required candidates to identify the direction and normal vectors and use them to find the angle between the line and the plane. Very popular question. Weakness was failure to extract the correct vector that is the normal to the plane. That is normal to the plane. So normal vector are the coefficients of x, y, and z. Failure to use the dot product sign. So dot product sign. Dot product sign. Now here, this is what I didn't tell you. Did you see this? My dot was visible. Dot was visible. So make sure you put a dot here. But here you don't put a dot because these are magnitudes. A dot is put between two vectors. So a dot has to be visible always. Failure to use the correct, we've seen that. Failure to obtain the complement of the angle. So complement, that is why I began by saying 90 minus theta. You see this? 90 minus theta to get the complement. Advise to teachers, illustrate to students angle between the direction line and the normal. So angle between the direction and the normal is what we call 90 minus theta. Then also identify the vectors above and explain their purposes in the given situation. Differentiate between the methods of dot and cross product. So if, let me tell you something, here if vectors can only be crossed or multiplied. So if I put a multiplication sign here, it is not called multiplication, it is called crossing two vectors. But my interest is dotting, so these two must be well distinguished. If I put product, it means, if I put this, it means I'm going to cross. So a dot has to be visible. Always remember that. That was question 4. Now question 5. Solve the inequality, this one. So the good thing, they have helped us by putting everything on one side and factorizing for us. For us, what we are supposed to do is to get the critical values and tabulate. So you put there these factors here, this, and that. Then the whole expression, the whole of this. These ones, you see, they are arranged in ascending order. So shall begin by values less than the smallest. Values less than the smallest, I can use -2. -2 here, I get a negative. -2 here, I get a negative. -2 here, I get a positive. So everything now gives you a positive, because this time this is positive. Then values between this and that, I can use 0, 0 here, positive, 0 here, negative, 0 here, positive. So in the end, it will be negative. So now I shall go to values between this and this. Here you can use 3. So when I use 3 here, I get a positive. 3 here, I get a positive. 3 here, I get a positive. Therefore, overall will be positive. Then what about values after this? I can use 4. 4 here, positive. 4 here, positive. 4 here, negative. And overall now be negative. Now, getting the solution set, do you see this? It is greater than, meaning positive. Greater than 0 means positive. So I look for everywhere where there is positive, and that is what is required. That's how we could get the 5 marks. So that was under, so question analysis. This one required candidates to obtain the critical values of a given inequality and use it to test, and use the test table to determine the solution set. Very popular question. So inequalities is under algebra. Weakness of candidates: failure to form the correct range in the test table. So critical values should be arranged in ascending order. Arranged in ascending order. That's when you can get the correct range. Then failure to identify the critical values and test for the correct range. So critical values are got by equating each bracket to 0 and get the value of x. Teach rational inequalities to the students. I think you already taught. So now we shall go to question 6. Question 6 is under calculus and says evaluate this with respect to y. So here this is a smaller powers, meaning that it can expand. If it was like power 5, we would introduce other methods, techniques. But now because it's a smaller power, the base is to expand to come up with that. Then this one, you cannot integrate it when there's this power. So we have to use double angle identity to remove the power. So I think you see this one is 3y. This has been doubled to give you 6y. That's what we mean by double angle identity. It becomes a half in brackets 1 plus cos 6y. Then I can calculate like terms. 1 plus a half gives you this. Then this one gives you that. And this one gives you that. Now I can integrate. So when I integrate, this gives me this. This gives me that. And this gives me this. Then I can substitute limits. Begin by the upper limit, put everywhere where there is y to give you this. Then lower limit, everywhere where there is y, you get 0. That's why there is minus 0 there. Simplify. Simplifying, this gives me this. This gives me this. This gives me that. So sine pi is 0. And sine 2 pi is 0. So end up with pi over 2 as the answer. And that's how you could get the 5 marks. Analysis. The question required candidates to integrate trigonometric functions with even powers by applying the double angle identity. So popular question, but weakness that there was failure to apply double angle identity to integrate the trigonometric expression. So when you forget double angle identity, there's no way you can proceed. Advice that illustrate the application of the double angle identity to integrate trigonometric expressions of sine and cos with even powers. Note this word, even powers. It is even powers where I use double angle identity. Odd powers, we use Pythagoras identities. Then question 7 is now under trigonometry and says, express this in the form that. That is now our formula. So shall I first make it equivalent. Note this symbol, equivalent. Then we expand this using compound angle identity to give you that. Then we can compare. Do you see this sine theta? It is here. Meaning that what is left this side is 2 and what is left this side is r cos alpha. So r cos alpha is equal to 2. Then same applies to cos theta. Cos theta, what is left this side is 3 and what is left this side is r sin alpha. So r sin alpha is equal to 3. Then you divide the equations to get tan alpha, which gives the value of alpha. Then you can use Pythagoras to get the value of r. Therefore, this come and replace r and alpha here. And that's what they wanted. So the question required candidates to express the sum of a given trigonometric function as a single trigonometric function using our formula. It was very popular, but there was failure to expand this using compound angle identities, and also failure to compare coefficients correctly. Failure to express r as a positive. So it is true, there are some cases where I will tell you that square root of a value should be plus or minus. That is okay. But when it comes to r formula, it must be strictly positive. So if I see this, it means that mark goes away. Let's see. Actually, there is not only one mark. Do you see this? This mark will go away, and this one will also go away. So 2 marks will be lost carelessly. So that is why I encourage you to go through these reports. They are available and freely accessed at the Uneb website. So me, I extract a few. I extract only the math because that's what we are uploading, math and physics. But those reports contain all subjects you do. All subjects done at Uneb are there. Okay, advise students that R is always positive and alpha is always acute. It is true that most of the angles, when they tell you to solve trigonometric expression, we get more than one angle. It is true, but in this case, it should be strictly one angle and strictly the acute angle. So question 8 is under calculus and says, use Maclaurin's theorem to expand this in ascending powers of x as far as the term in x squared. So shall let this to be fx, meaning that f0 means you substitute 0 here, you get ln 2. Okay, then differentiate that fx to get f prime x. So differentiate this, you come up with this, which can be written as that. Then f0 means substitute 0 here, you come up with this, which is equal to a half. Then differentiate the second time because they told you up x squared. So differentiating this, I'll come up with this. I believe by now you know how to do that. Bring down the power, reduce the power by 1, differentiate the inner bracket. Simplify to get this, then substitute for x as 0 to get this. So I'm reminding you that all topics of Math 1 are available on the platform. So if you have challenges in differentiation, go and search for that video under the playlist of calculus. Or you can inbox me asking for the links. My number is always at the front, at the first slide. So this is the expression for Maclaurin. It's also available in your logbook. Then substitute for this, and for that. And that's what they wanted. So remember to put these dots to show that it would have continued, but the question told us to stop here. So question analysis, the question required differentiation to obtain the coefficients of x that are necessary in Maclaurin's expansion by inserting x equal to 0. That's why you saw me putting there getting f0. Popular question, but there was weakness of failure to obtain the first and second derivatives of the expression. So you need to have mastered differentiation. Remember, calculus contains 3 questions in section A, 3 questions in section B. So by all means, you must learn differentiation and integration. Advice is to guide students on how to differentiate various kinds of functions. There are various techniques of differentiation and you must be well versed with them before you enter your Uneb examination. Now we have successfully completed section A and let's now embark on section B. For me, I'm going to do all questions as we agreed because it is revision. But when it comes to your turn in Uneb, make sure you only answer 5. Make sure you only answer 5. Okay, so shall I begin with question 9. Question 9 part A says, solve the equation this. And part B says, find the fourth roots of this. So this is under algebra and in particular coming from the topic of complex numbers. So solving, we need to first get one root. So let fz be this. When I substitute 1, I'll come up with 0. Because I get 0, it means that z equal to 1 is a root. Okay. So by synthetic method, there are 2 ways. You can either use long division or synthetic method. So using synthetic method, I'll put the coefficients of this here. Then I put my z equal to 1 here. Then bring this one here down. Multiply this one by this and put it here, which is 1. Then now add this to get -6, you put here. Now -6 times 1 gives you what to put here. Then add this to get 13. 13 times 1, you get what to put here. Then add this, you get 0. So what comes here is the remainder. So 0 means there is no remainder. Okay. So that means that now, okay, there are two alternatives. Let's also look at the long division method. You come and put the factor there and the expression function. Then you divide. This divided by this, you get z squared, which you put here. Z squared times the whole of this, you get z cubed minus z squared. Then you're going to subtract. You'll come up with this. So this minus this is 0. This gives you this. Then these ones come here. Then again, repeat the procedure. This divided by this, you get -6z. -6z times the whole of this gives you this. Repeat the procedure, pass, subtract, you'll come up with that. Then repeat. This divided by this, you get 13. 13 times the whole of this, you get that. Subtract, you get 0. So those are the two ways. Now what are the other roots for this? Other roots you can use quadratic formula. We prefer quadratic because factorizing is not so okay. I think you will see even here we got complex roots. So factorizing is the best. Therefore the other roots are z equal to 1, z equal to 3 plus I, and z equal to 3 minus I. And that's what they wanted in part A. Part B, they wanted the fourth root. Let's first go back. Part B, they wanted the fourth root of this. Okay. Fourth root. So you need to first get the magnitude of this complex number. Magnitude of this gives you this, which becomes 16. Then the argument also. Argument, you have to first identify the quadrant where it lies. Do you see? It is negative followed by positive. Negative real, positive imaginary. Meaning it is in the second quadrant. So second quadrant, it should be 180 minus arctan, the magnitude of this ratio. So you come up with 150 degrees as the argument. But we know, okay, this is just a reminder. You don't need to write it, but that is what we know from demo V. So fourth root means that fourth root O to power quarter. It means that now for the modulus you put a power. For the argument you multiply by a quarter. That's why you see here division, dividing by 4. But note something. Here it is 150. Why have we added this? It is because we use what we call a general angle. General angle must have this such that each time you put n, you get a different angle. So general angle is angles after that revolution. So at first it was this. Then we get the second angle to be, first make a revolution, which is 360. Then you go back to that. That's why you say 360 times n, where n means the number of revolutions. But more explanation is there in the video for complex numbers. So simplifying, this gives you that. So now that I've got that, I can now get for different values of n, beginning from n equal to 0. So for n equal to 0, where there is n, you put there 0, you come up with that, which becomes the first root. Then for n equal to 1, you come up with this as the second root. For n equal to 2, you come up with this as the third root. And for n equal to 3, you come up with this as the fourth root. So they ask for 4 roots, so that's where you stop. So analysis, part A required candidates to solve cubic equations by inspection and long division. I think you saw what I did. Let me show you something. So did you see this? This is what they call inspection. Some of you are funny. Do you know what you do? You just press OK shoot and get the roots. Now that means that very many marks will be lost. Do you see the first mark? The first mark begins from attempting to find the first root. Now when this is 0, even this should be 0, this should be 0. So you end up getting 0 out of 6 simply because you chose to use a calculator. So don't use a calculator, use inspection and long division or synthetic method. Okay, then part B. Part B required candidates to apply De Morville's theorem to find the fourth root of a complex number. Both parts were popular, meaning they were attempted by many, but there were some weaknesses. One was failure to identify one of the roots. That inspection of saying z equal to 1 was a challenge. So you have to first use the calculator to get a real root. That's what you write in the inspection part. Then failure to use long division correctly. So you have to master long division. Majority assumed the root was a complex number. It is not okay. Then some candidates were using calculators. This is where problems come from. Using calculators is not okay. So here it was saying calculators and quadratic. This was a mistake. It would have been using calculators instead of quadratic formulas. Instead, or using calculators to solve quadratic formula or use to call quadratic equations. So this and was a mistake. It should have been instead of quadratic formula. So we must use quadratic formula. Then failure to obtain correct argument. Argument, remember, you must identify the quadrant where the complex number lies. Failure to do that, the argument will not be okay. Then failure to find the roots accurately. So you must use the calculator correctly to get the correct roots. To many decimal places, not rounding off to a whole number. No, that is not okay. So you don't round off to a whole number. Advise, guide students to use inspection while solving. So don't just use the calculator. Then another advice, teach the application of De Morville to find the nth root of a quadratic equation. I think that we are well versed with it. Illustrate the purpose of an Argand diagram in identification of the quadrant. I think you saw me doing something like this. To know the exact quadrant, because here most trigonometric functions we write 2 angles, but here it is not okay. We need only one angle, which is called argument, and you can get a correct angle by identifying the exact quadrant where the complex number lies. So question 10 says express fx this in partial fractions and hence find this integral. Now if the question was stopping here without the hence part, it would have been under algebra. But because there is this hence part, which is integration, it now goes to calculus. So one thing you should realize is that this is an improper fraction. Do you see this? Highest degree is 3, highest degree is 2. So it is improper. Each time it is improper, the first thing we expect you to do is called long division. So by long division, I'll come and put the divisor and the polynomial or the function. Then I'll divide this, divide by this. I'll come up with negative 3x. Now negative 3x times the whole of this, you come up with 3x cubed minus 3x squared. Then repeat the procedure. Sorry, subtract. When I subtract, this goes away. I'll remain with this. Do the same. This divide by this, you come up with negative 5. So negative 5 times the whole of this divisor, you come up with that. Subtract. You come up with that as the remainder. Now here you cannot proceed because this one is smaller than this. So next is to write it down that fx is equal to this one plus this remainder over the divisor. Now the partial fractions we are interested in is now for this, because it is now a proper fraction. So equate the numerators, equivalence of the numerators. Then you need to get the values of a and b. So putting x equal to 0, I come up with a as 1. Putting x equal to 1, I come up with b as 3. Therefore, fx is equal to that. And that's what they wanted in part A. Then for the hence part, hence they wanted you to integrate. So integrating, that means where there is fx, you put there the whole of this. Then you start integrating. Integrate this, you come up with this. 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 And that is it. Remember to put the constant of integration. So question analysis: required candidates to express an improper fraction in two partial fractions and hence find the integral. Very popular, but there's a weakness of failure to recognize an improper fraction. So before you begin anything, first check the highest degrees in both the numerator and the denominator. Then also failure to convert the fraction into a mixed fraction. Then failure to express the fraction into partial fractions, and failure to integrate the function. So advice is that teachers should expose students to different types of fractions that should be expressed into partial fractions. And those are variety of those questions are available in the topical question bank, which I sell, and also the Mastering A-Level Mathematics Paper 1, and also on this platform. So there's no excuse for that. Then teachers should guide students in using different methods of integration. I think you'll see this one had a variety. It had where you are supposed to use the increase the power by 1, divide by the new power, and also you're supposed to use the natural logarithms. So variety is needed. So now we shall go to question 11. Question 11 is under vectors. It says a point E has coordinates this. A line through E and parallel to the line whose equation is this, okay, meets the plane this. At a point B, a perpendicular line from E meets a plane at point C. Okay. Determine the coordinates of B then and C. As simple as that, and you get your 12 marks. So 1, it is better to sketch. A sketch will not carry a mark, but it helps you not to misfire. It helps you not to misfire. So we have a plane and we have a line with direction that. We have another line with the same direction and passing through. So they told us that a point E has coordinates that, which is there. A line through E is parallel to another line with equation this. So this line through E is parallel to this line. That's why you're seeing me putting the same direction vectors. And they said it meets the plane at point B, which is here. A perpendicular line from E meets the plane at C. So we shall come and draw a perpendicular line from E to meet the plane at C. So this vector is parallel to the normal vector. So they have the same direction. Okay, determine the coordinates of B and C. Okay, with that sketch we shall come and say, let us first get the direction vector of this given line. Here the direction vector is this 2, here this over 1. So 2, 1, it's negative 2, 1, 2, which is that. Okay, then vector equation of line BE. I think you know that vector equation we need a direction and a point. So we need a point on the line and this direction. Point was given, point E was given, direction is now known. So that becomes the vector equation of line BE. Parametric becomes that 2 minus 2 lambda, then 1 lambda, negative 1 plus 2 lambda. So at the point of intersection of line BE and the plane, it implies that these ones should satisfy this equation of the plane. So come and substitute for x, for y, and for z. Then expand and simplify to get the value of lambda. After getting the value of lambda, I can now get the coordinates of B. So when you put lambda here, I will get the values position vector of B, but they want it in coordinate form. And that is it. So you've got the coordinate of B, we also need the coordinates of C, which is this point. So still we shall follow the same procedure, get a parametric coordinates of point C, but get parametric equation of line EC, substitute in the equation of a plane, and then get the value of lambda and substitute for lambda, like that. Just the same way as we have done for line BE. So you shall come here and say for line BC now, for line EC, this is now the direction. The normal to the plane is the direction vector of the line. So from this, normal vector is that, okay. Therefore, vector equation of line CE will now be OE plus scalar, then the direction vector, which is that. Parametric equations are those, then at the point of intersection, it implies that these values satisfy the equation of a plane. So substitute for x, y, and z. Then simplify to get the value of mu. Then substitute that mu here to get the coordinates of point C. That's the position vector, but we need coordinates, which will be that. And that's why they want it. So question analysis, the question required candidates to determine the equation of a line parallel to a given line. Then 2, to obtain the coordinates of the point where a line meets a plane by substituting the parametric form in the equation. So weakness was failure to determine the equation of the line parallel to the given line and also perpendicular to the plane. So you know that our equation of a line perpendicular to the plane, its direction vector is similar to the normal vector of the plane. And two parallel lines have the same direction vectors. Then advise teachers to explain to students the concepts of parallel lines, illustrate lines perpendicular to plane, and those that are parallel to the normal vector of the plane. So that was question 11. Now we shall go to question 12. Question 12 part A says, 4 different mathematics books and 6 other different books are to be arranged on a shelf. In how many ways can the mathematics books be arranged on a shelf? So one, you should realize there is something called arranging, and 2, you should realize there is something called picking from the many and arranging those few. So that becomes permutation. So of the 10 books, you are going to pick 4 and arrange them. So it becomes 10 permutation 4, which is 5040 ways. Then part B, on a certain day, Fatuma drank 6 bottles of the 9 bottles of soda available. Then on the other day, she drank 5 bottles of the 7 bottles of soda available. In how many ways could she have chosen the bottles of soda to drink in the 2 days? So from this one, there is nothing like arranging, okay? So yeah, of the 9, she drank 6, which is 9 combination 6. Then of the 7, she drank 5, which is 7 combination 5. And you multiply the 2. So number of ways will be 9 combination 6 times 7 combination 5 to give you 1764. That is part B. What about part C? Part C says, given that 20 combination R is equal to 20 combination R minus 2, find the value of R. So that is what we have. Then we expand it. This means 20 factorial over 20 minus R factorial times R factorial. This one becomes 20 factorial over 20 minus, in brackets, R minus 2 factorial times R minus 2 factorial. So this factorial 20 factorials can cancel. When they cancel, you remain with this one now equal to this. Then 2, I need to also remove some factorials. So I'm going to expand this side. 20 minus R is here times R factorial. So R factorial can now be expanded to become R times R minus 1 times R minus 2 factorial. We stop at R minus 2 because we also have an R minus 2 here. Then this side we are going to expand this to become 22 minus R, then 20 minus 1 you get 21 minus R, 21 minus 1 you get 20 minus R factorial. We stop at 20 minus R factorial because we have some 20 minus R factorial this side. Then you can cancel now. This factorial goes with this factorial goes with this factorial, and you will remain with that. Open brackets and collect like terms to get the value of R, and that's what they wanted. So question analysis part A required kindness to apply permutations in the given situation. Part B required kindness to determine the product of combinations. And part C required kindness to expand, simplify, and solve equations involving combinations. The weakness was failure to interpret the question in different perspectives. Interpretation was a challenge. 2. Failure to multiply the combinations formed. Majority of candidates were instead adding. 3 was failure to simplify the derived expansion in combination. Then advise the teachers to differentiate between use of multiplication and with and, condition, and addition with or condition. So you should know when to use multiplication and when to use addition. Then teachers should expose students to all concepts of permutations and combinations. So that was question 12. Now we shall go to question 13. Part A says, a curve is given by the parametric equations, these ones. Find the Cartesian equation of the curve. So a Cartesian equation means that you eliminate the third parameter, which is t. So you have two parametric equations, the x and that. So you need to eliminate t. The first thing to do, I think you can see that this is similar to this. So I'm going to substitute equation 1 into equation 2 to come up with y is equal to tx. Make t the subject to come up with that. Now substituting for t into equation 1, I'll come up with that. Cross multiply and rearrange. And that is it. So that's what they wanted. Okay, that was part A. Part B says, a point P is such that, so this question is under geometry. A point P is such that its distance from the origin is 5 times its distance from 12, 0. Roman 1, show that the locus of P is a circle. Roman 2, determine the coordinates of the center of the circle and its radius. So here, this is where the trick is. Point P is such that its distance from the origin is 5 times its distance from the coordinate 12, 0. So I have the origin 0, 0. I have a point given which is 12, 0 as A, and point P which is variable x, y. So distance OP is 5 times AP. So come and substitute OP, distance OP is that, distance AP is that, but don't forget the 5 here. To remove the square root, we square both sides. This 5 now becomes 25. Open brackets and collect like terms. So this one is now a circle. Okay, I can even reduce to get that, but even if you stop here, it is okay. So since, how do you know that's a circle? The coefficients of x squared and y squared should be equal, and the rest of the terms must be linear. There you have shown that it's a circle. Then they want the radius and center. So by comparing with the general equation of a circle, you realize that g is, remember this is 2g being equal to negative 25, so g is negative 25 over 2. F here, there's no y here, so that means it is 0, so 0 over 2 is 0. C is this constant, which is 150. Therefore, the center is negative g, negative f, negative g, negative f to give you 12.50. Then the radius is given by this expression, substitute for g, f, and c to come up with 2.5 as the radius. And that's what they wanted. So question analysis part A required candidates to eliminate t from the parametric equation. So that's when it's a Cartesian equation, you have to eliminate the third parameter. Part B required candidates to apply Pythagoras theorem in obtaining the relation between the distances. of a general point from the origin and from a given point. So weakness was misinterpretation of the question to involve parametric differentiation. So differentiating that is not now that is off track because this was under geometry. So you should know the section or the part where a question is coming from. Next weakness was failure to eliminate t from the parametric equation. So you need to know how to eliminate. Then next was candidates were interchanging the given distance ratios. So if you say 5 OP is equal to AP, that is now already interchanging. The 5 was supposed to be on AP. Then failure to interpret the stated conditions in the question. So you read the question and clearly understand it. Advice is that teachers should illustrate the elimination of parametric to obtain locus of a point in the Cartesian plane. Then also expose students to various coordinate geometry concepts applicable in locus conditions. So locus is all over geometry, so it can't be avoided. It cannot be avoided. Then teachers should demonstrate the use of sketches for clear interpretation. Like I told you, a sketch may not carry a mark, but it helps you not to misfire or not to misinterpret the given question. So that was question 13. Now we shall go to question 14. Question 14 says, given the curve this, determine the coordinates of the turning points of the curve and then the equation of the asymptotes and hence sketch the curve. So this is now under calculus. So to differentiate, this is easier if you bring the power up, bring the whole expression up using negative indices. Then you differentiate, for example, procedure, bring down the power, which is -1, which you see here, reduce the power by 1 to get -2, differentiate the inner bracket to get 8x, simplify to get this. So shall remember that at turning points, dy dx is 0, so substitute, equate this to 0 to get the value of x, which is 0. Then we need the nature of the turning point, so shall come and use the tabulation. So yeah, L means a value on the left of this, R means a value on the right of this. So I can use a -1 and I use a +1, like that. My interest is the sign of dy dx. So when I use -1, I'll get a positive sign. When I use +1, I'll get a negative sign. So the nature will now become positive gradient, negative gradient, giving you a maximum. But I need also the y coordinate of the x value. So when x is equal to 0, y will be -1. Therefore, the turning point is this, and this is our maximum. Part B, they wanted the asymptotes, yeah? They wanted the equation of the asymptotes. So I'll say this one can be factorized to give you this denominator. So as y tends to plus or minus infinity, the denominator equals to 0, giving you this and this as the vertical asymptotes. And as x tends to plus or minus infinity, we get 1 over infinity, which gives you 0. So y tends to 0, therefore y equal to 0 is the horizontal asymptote. We need to get the region where the curve lies, so we shall use critical values. Now, critical values are got from the vertical asymptotes and the x-intercepts. But the funny thing is that this one does not have x-intercept because when y is 0, the whole of this vanishes away. So it doesn't have x-intercepts. That's why you're only using these vertical asymptotes as critical values. So the region where the curve lies, we shall draw a table and put there the factors and the whole expression of y. Then before negative a half, I can use negative 1 here. You get, I'm choosing the sign, negative 1 here, you get a negative. So in overall it will be positive. What about between negative a half and positive a half? I can use 0, 0 here, 0 here. So overall is negative. What about beyond positive a half? This I can use now 2 or 1 here to get that, 1 here to get that. So overall is positive. Like that. Then required sketch now. Let fx be that. And now we draw the axes, label them. Our interest is to put only the necessary points. So let's put the asymptotes. There was x equal to negative a half and also x equal to positive a half. Y equal to 0 is the x-axis. So we don't need to do it there. So note that the asymptotes are dotted. Then in this region it was positive, so it is above. In this region it is negative, so it is below. And it has a turning point. In this region it is positive, so it is above. And that is what they wanted. So question analysis required kindness to evaluate x, y, and y dx is equal to 0. Then also to obtain the corresponding values of y while finding the turning points of a curve, or use the method of region of restriction. Then also to determine the equations of the horizontal asymptotes and the vertical asymptotes. Then also to derive the nature of the curve and the region of existence. Then hence sketch the curve. So weakness was failure to differentiate the function of the curve and hence wrong turning points. So differentiation, you cannot run away from it. Then failure to generate the equations of the asymptotes and also to sketch the failure to sketch the curve using the derived conditions. Advise that teachers should illustrate to students how a sketch function from their inverses. I think it was brought some years back, but maybe it may come, maybe it may not. So you should also be well versed with it. Then also teachers should elaborate the procedure of curve sketching. So the steps we need the turning points and the nature, we need the intercepts, we need the asymptotes, and the region where the curve lies. Then question 15. Question 15 is under trigonometry. Part A says, show that this is equal to this. Let's begin with that. So tan 3 theta is equal to 2 theta plus theta. So use compound angle to come up with this. Then from there I use half angle to get for this. Half angle for that, half angle. Then from there I get LCM for the numerator alone. Note that I'm using brackets. So use brackets very well. So it's not okay to write something like this. Maybe 4, 3, 2, 7. That is not okay, because you cannot know which is which. That's why you put a bracket here to show that the whole of this is a numerator, and put a bracket here to show that the whole of it is a denominator. So use brackets very well. So here what I've done, I've got LCM of this to put them under one LCM, also the denominator. Then you realize that this and this are common. So I can cancel them out, remain this as the numerator and this as the denominator. But you can reduce further. So this plus tan theta gives you 3 tan theta. Then also this times this gives you tan cubed theta. What about here? Here I have 1 minus this minus that to give you -3 tan squared theta. Factorize out tan theta in the numerator, you come up with what was required. Then part B says solve the equation this for values of theta ranging from 0 to 180. So alternatively, this is just an alternative. You can still first say tan is equal to sine over cos. It also works. Then you expand sine. This identity is there in the logbook. This identity is there in the logbook. Factorize out sine and cos to come up with tan with this. So it's just an alternative. Then multiply up and down by 1 over cos squared theta so that this becomes sec and this becomes tan. This becomes 1 and this goes away. This becomes sec. Then you remember that sec squared theta can be expressed in terms of tan, like that. So it may be a little long, but you'll still get the same proof which they want, like that. Okay, so my interest is the part B, where we're supposed to solve. So one, I'm going to combine these ones and use factor formula to get this. Then I realize that this and this is common, factorize it out. That means that either this is 0 or this is 0 to get that. Then for cos 4x equal to 0, I'll get 4x being equal to this. Now, how do you know where to stop? You say 180 times 4. 180 times 4, it gives what? It gives 180 times 4. It gives 720. So I shouldn't exceed 720. That's why I stopped at this. Then divide throughout by 4 to get that. Then for this one, also 2x is that. Divide throughout by 2 to get that. And that's what they wanted. So question analysis, part A required application of either compound angle formula or double angle formula. Then for all identities of this and this, I think I'm going to use those alternatives. Or dem of this is also allowed, though I've not done it. Then part B required the use of factor formula with the identification of pairs that can produce a common factor, or converting to uniform angles to solve the quadratic equation. Weakness was failure to apply the above trigonometrical methods. So trigonometry, you need to have practiced enough. Failure to identify the necessary pairs to a common factor, and failure to exhaust all the required angles. So you must exhaust all the angles, otherwise some marks will be lost. Advice that encourage students to refer to relevant trigonometric identities in the math logbook. Then also guide students to evaluate in the evaluation of various trig equations. Then elaborate the necessary listing of all the multiple angles in a given range for possible roots. Then question 16. Question 16 is under calculus, and that in particular it is differential equations. So it says the rate at which a body cools is proportional to the amount by which its temperature exceeds that of its surrounding. The body is placed in a room of temperature 25 degrees Celsius. After 6 minutes, the temperature of the body dropped from 90 degrees Celsius to 60 degrees Celsius. Part A, form a differential equation for the rate of cooling of the body. And part B, find the time it takes for the body to cool from 30 degrees Celsius to 40 degrees Celsius. Okay. So differential equation, the rate is proportional to this excess. Then put a constant of proportionality. It should be negative because as time increases, temperature reduces. Then part B, now we are going to solve. Put integrals, called rearrange. Put this dt this side and this theta this side and put integrals on both sides. Then when you integrate, this gives you ln that, this gives you negative kt plus c. So initially t is equal to 0 and theta is equal to 90. So substitute for theta and for t to get the value of c. Then replace c in this equation. Okay. Then after 6 minutes, t is equal to 6 and theta is 60. So substitute for, in this one now, substitute for theta and for t to get the value of k, which is that. Then you can go rewrite it with now, this is now called the particular solution. Simplify. So what I've done, I've brought here, what I've done, I've taken the whole of this side to make this t positive and brought this on this side to get this. So t is that. Therefore, when theta is 40, I can get the value of t, which is that. And when theta is 30, I can get the value of t, which is that. Then time taken will be got by subtraction to give you that. And that's what they wanted. So question analysis required kindness to define the variables of for temperature at any time. Express the rate of cooling as proportional to excess. Then solve the differential equation and use the boundary conditions to determine the value of the constant of integration. Then write the particular differential equation. Then obtain the time interval between this and this using derived differential equation. The equation was very popular, but failure to interpret the temperature differences. Then also failure to obtain the particular differential equation. Failure to express the constant of integration with the necessary decimal places for accurate results. So don't overround off. Failure to calculate the correct values of time. Then advise that teachers should encourage students to round off to at least 4 significant figures, unless required otherwise. Then advise students to explain the concept. Teachers should explain the concept of excess temperature. That's why you saw me writing theta minus 25. And this integration in the application of differential equation. This integration is about rate of decay. So that has been our paper for paper 1. So general remarks is that 1, questions are from 5 parts: algebra, geometry, trigonometry, analysis, which is calculus, and vectors. So performance of students in 2023 was comparable to that of candidates in the previous year. Then the quality of work presented by the candidates was likewise comparable to that of the previous year. Then the paper was of the same level of difficulty as that of the previous year, and the time allocated was adequate. So don't be there and say the time given is very small. It is adequate. Then what I'm interested in is this one, that the quality of work presented was likewise comparable to that of the previous year. We expect to see an increase, so it should be better than the previous, because now for you, you know what made those students misfire. So I encourage you to, as you prepare for your Uneb of 2024, make sure that your quality of work is of the required standard.